In the last video, we talked about the normal distribution, and as we were talking about the normal distribution, what we were saying was there is a chance whenever we're looking at what has happened to our descriptive statistics in the past, that maybe when we take a sample, we really aren't getting a very good indication of whether or not we have improved, if we've changed, something like that, just because we don't have all of the data. Instead, we have a sample of it. So here's kind of just a real quick reminder of what we had. We said that the normal distribution looked like this, where 50% occurred below the mean, 50% occur above the mean, that there's a concept here that's beginning to play out, that is the number of standard deviations that we are away from the center. We oftentimes refer to this number of standard deviations that we are away from the center as a Z statistic, okay, a Z statistic. The Z statistic tells me how many standard deviations one data point is away from the mean. So again, I'm going to have a data point, the X value. I'm going to subtract away the mean, and then I'm going to just divide it by the standard deviation. So right here in the middle, 4.18, $4.18, has a Z value of a 0.0 because I have 4.18 where I'm starting. My mean is 4.18. All right, so I have 0 divided by 0.84. That's a Z statistic of 0. What happens if I go down one standard deviation? $4.18 minus 84 cents is $3.34. That gives me a Z value of minus 1.0. You can see from this, I don't have to go down exactly one standard deviation. I could calculate the Z value of $4.02, $5.68, something like that, and I can calculate the Z. The Z is important to me, once again, because it tells me how many standard deviations I am away from the mean, but there are also probability tables. Again, this matters to me. 50% occurs up to here, right? 50% occurs on up to this point. Let's look at that from a Z table perspective. If I looked at a Z of 0.00 in a Z table, and you'll find this in your textbook in Appendix D, you'll see that a Z of 0.00 is 50%. What it's saying is that cumulatively, if I calculate the Z is exactly 0.0, 50% of all occurrences are going to occur less than a Z of 0.00. Now this table you're just going to have to take for granted. This has been calculated by people many years ago. It gets confirmed. The calculation of this can be done by hand. It is difficult. You won't ever calculate your own percentages here. Instead, what you're going to do is you're going to take a Z table and look up a value, okay? For example, let's say that you calculated a Z value of 0.91. You'd go to your textbook, you look back in the Appendix D, a Z of 0.91, and it moved, is a percentage of 0.81859, which is approximately 82%. Okay? Again, that's what we're going to do. We are going to use these values that we had before, okay, when we started talking about where we are in accordance with the normal distribution, and we're going to calculate Z statistics, how far away from the center we are based on the value that we're looking at, okay? That gives us a little bit of an idea of how we're going to take this normal distribution, calculate a Z statistic, and then use a Z table to look up the values. The very next video, we're going to start actually applying this to where it starts making more sense.